That's number 8. Yeah, so rectangle has a length of 3 and a width of 8, so we can first draw L. So something like this. 3 centimeters, 8 centimeters. So if the width multiplies by 3 over 4, right? But the area of the rectangle remains constant, what is the new length? So by this statement over here, the area of the rectangle remains constant. I think you should be able to recognize that this is a inverse proportion question. So I'm just going to write IP. So what is the new length? Well, since the area, right, is equal to length times width, and then we are told that the width is multiplied by 3/4. So as long as we figure out the new width, we can find out the new length. Because the area is always 8 times 3, which is 24 centimeters squared. Okay? So I'll just erase this for now. So the width, oh, it should be quite simple. So you just use this to multiply it by 3/4. Nothing fancy. I didn't use any like factor of 3/4 or anything. Just multiply. So all you have to do is multiply it by 3/4. I guess maybe the tricky thing here is the fraction, but I hope you guys are okay with the fraction. So when you multiply by a fraction, it's the top and then the bottom stays the same in this case. So that's the new length. And then now all you got to do is solve an equation. So the area is always 24 centimeters squared. And then, so 24 is equal to the new length times 9 over 4. And again, here, I think the only problem would be with the division of fraction. But like, so like here, I write it like this. It might be a bit confusing for you. How I like divide and then there's another, like a line here and line here. But you can also write it like this. Oh. So if it makes it better for you, you can go for, so you can do 24 and then divided by, you can write it like this as well. It means the same thing. So and then equals to L. So divide 9/4 on both sides. So when you divide a fraction, that is the same thing as multiplying by the reciprocal. So when you switch the numbers around. So 24 times 4 over 9. And that is equal to L. Oh wait, no, there's a 9 over 4 here. My bad. So you just do this and then you will get, so actually you can cancel out a 3 over here. So divided by 3, divided by 3. And that's about as simplified as you can get. And the length is, the new length becomes 32 over 3. And wait, is that right? Let me check the answer key. Doesn't look right. Did I do something wrong, guys? Wait, that's not right. The width. Oh, wait. My bad. Never mind. Yeah, it doesn't make sense here. Yeah, not 3. It's the width multiplied by 3/4, so it's the 8. Ah, that was why. Sorry about this, but the process is essentially the same. Okay, so instead of multiplying the 3, you multiply the 8. So 8 times 3/4 is equal to, so you cancel out here, equal to 6. Oh, yeah, no fraction, yeah. So the only fraction you have to deal with is in the first step. And area is still 24, that doesn't change. And then the new width is equal to 6, so 6 times length. And then you just divide 6 on both sides. And then length is equal to 4. So the key is to recognize this statement. The area of the rectangle remains constant. So this means that it is an inverse proportion question. And then now all you got to do is find the constant of proportionality. So that's like the constant product here. And then you can just solve the equation. And yeah, so the other question I want to look at is number 9 over here. This one. Number 9. So 4 workers can finish a construction project in 9 days. And so how many workers are present if the project finishes in 12 days instead? So here I didn't say anything about like a constant product, like I didn't use this word specifically, or anything about like a constant uh, quotient, so like for direct proportion. But the thing I want you to notice here, so this is like when you get to your harder questions, they're not gonna tell you what uh what method, what type of question it is. You have to figure out from just imagining what it would be like. So originally it was 4 workers finishing it in 9 days, right? Now, so how I would this question is actually a bit strange. Like usually you would say, so 4 workers can finish a project in 9 days. So how long will it take for 6 workers to finish the project? Or how long will it take for 2 workers to finish the project? I think that would be a more intuitive sense, right? But how I did it here was asking you to find out the number of workers instead. So that I guess that is a bit confusing, and that is the tricky part here. But then you have to, so before we think of this, maybe we can think of the other question. So the question I just posted, that I just asked, right? Uh, so let's imagine what happens when there are 3 workers. Well, no, let's go up first. So 6 workers. So if you have a project, the length of the project stays the same. So yeah, that was kind of uh the my bad. It was I didn't specify this, but then I did say it during the quiz last time. So the duration stays the same. So when you have more people working, like just imagine I guess a school project. Ideally speaking, right? If you have more people working, that would mean less time, right? Now what happens when you have less people working? Well, that means for each person they have to do more work. And when you do more work, you need more time for the total project. So because the duration stays this, well, yeah, well, not the duration, I would say the size. Yes, the size of the project, not the duration. My bad. Yeah, so the duration doesn't stay the same. The duration is the time it takes. So if the size of the project stays the same, then when you have 2 workers working, then you need more time, right, to finish the same size. Whereas when you have 6 workers, that is more than 4 workers. And when you have more people working, ideally that would mean less time. Now, so look at this question now. So, and then this relationship, when you have one quantity goes up, the other quantity goes down. So quantity A goes up, quantity B goes down. And then here, quantity A goes down, quantity B goes up. Now, so this, well, what is this pattern over here? This is inverse proportion. So if we look back at the definition of inverse proportion, so let me just find it here. This one. Oh no, is it this one? No, it's not this one. Sorry. Yeah. Yeah. So inverse proportion, right? So when one quantity goes up, the other quantity goes down. So and then they have a constant product. So this is a definition of inverse proportion here. So in this example, it actually defines an inverse proportion. So with this means that this question from this observation, right? So first you have to make these observations. You have to make these observations. So that's not good. And then from this you can deduce that this is an inverse proportion. So this observation part is actually the key, because once you make this observation, you can find the constant product now. So you can find the constant product. And you can just multiply the two quantities, even though it might not make sense what it means, but that's just the constant product. We're just trying to build a relationship between them, an inverse proportion relationship. So workers times time. Is that the original one is 4 times 9, right? So 4 times 9. So that's going to equal 36. So then from this point on, you just plug in 12 into the equation. So instead of 9 days, now I have 12 days to finish. So times 12 is equal to 36. So now I divide both sides by 12. So the number of workers is equal to 3. And then now, so you got to go back and check if this answer makes sense, right? So, oh no. So that's the answer here. But does it make sense? Well, so initially 4 workers can finish the project in 9 days. So now you have 3 workers, so that means there are less workers. So theoretically, that means it's going to take more time, because you have less people doing the same amount of work. So one person has to take more time to do the work. So yes, that makes sense, because the project finishes in 12 days instead. That is more than 9 days. So that is the answer. 3 workers. So any questions on this? Any questions about this one? I think this one is well, it's number 9, so it's one of the hardest questions on that quiz. Oh, are you saying something, James? Hey, you have your mic on.
Sorry.
Oh, it's okay. Yeah, so no question, right? I hope this makes sense. So this is the key over here. Make observation. Oh, that doesn't look nice, but it's okay. So now the other thing is, when you guys submitted the answer first, you thought that this is a direct proportion. And when you thought this is a direct proportion, you figure out something like a 5.3 repeating, right? Like, I think this is the answer a lot of you got. Yeah, but anyway, so it was not a whole number. There was a decimal over here. So the other thing you have to recognize is that how can there be a 0.3 repeating of a person? Like, I think this intuitively should not make sense. So, like, you can either have 5 workers or 6 workers, but you cannot have 5.3 repeating of a worker. So when you get this answer, this type of weird answer, and I hope this will strike you as weird, then what you got to uh, ask now is the question correct? Well, first, actually, first I will ask yourself, am I doing the right thing? So, am I doing the right thing? Like, why am I getting this? Is there like a calculation mistake? Or in this case, have I like misunderstood the question entirely? Now, the other thing you can ask yourself is this question correct? Now, so I'm going to admit that I'm not perfect, so not all the question I make will be entirely correct. So sometimes I might make a mistake. So that was why, like during the quiz, like you guys can ask me questions about like some stuff you don't understand. So, but then the one thing you don't want to do is to accept this as a correct answer, because I hope that this is to you that does not make sense and this should not be correct. So either so when you get a maybe I can write it down. So ask yourself. Or so am I doing the right thing? Or the other thing is so people make mistakes, and then that includes the people creating the questions. So it's always good to recognize that sometimes it might not be you who's making the mistake. Sometimes it can be the person creating the question. But most of the time, I can guarantee you that it's the first thing that is more more probable. So you doing the not doing the right thing is more probable than the person creating a question. But that is not saying that you might be wrong. You might be correct, and then the person creating a question could be wrong. That is also that also happens. And yeah, so so this is the thing with checking your answer. Like when you finish a question, you don't just want to go to the next question. Like even if you're short on time, you always want to make sure that your answer makes sense. Like this is obviously should not make sense. And then so for this type of word problems is perhaps a little less not as easy to check over your answer. But when you solve an equation, like say you solve like something like I don't know, 2 minus x is equal to 3x plus 1 over 7x minus 9. So like this seems like some like kind of a challenging uh, equation, I'm gonna say. Not challenging, but it's gonna take a bit of work. So when you get to an answer, I don't know, like x is equal to 2. I'm pretty sure this is not the right answer. Yeah, it cannot be right. Because 2 minus 2 is 0, so you cannot divide by 0. Then you want to plug this answer in. So you want to plug it back into here. Plug it back into here. To check whether they are equal, right? So maybe not 2. Let's say that this is equal to 4. Okay. So you plug this in. So 4 times 4 is 16. 16 minus 3 is 13. So 13, and then the bottom is equal to negative 2, right? 2 minus 4 is negative 2. And on the right side over here, you have 3 times 4 is 12, and then plus 1 is 13. And then 7 times 4 is 28, and 28 minus 9 is 19. So the left side and the right side, well, they're not equal. So that means your answer is wrong over here. So when you solve an equation, like maybe if you are rushing through, then you don't have to check, but it's always a good idea to, if you have time, to plug in the number and see if the left side is equal to the right side. And that should be a very straightforward check. And if they're not equal, that means you have done something wrong. Okay, so that is kind of the two questions I want to talk about. Are there any questions that you guys want me to explain from the quiz last week? No question? Okay. Well, I guess I'll move on then. Then the other thing I want to talk about is some of the homework questions. Not many, just a few. So maybe, yeah, I'll focus on these 4 over here. Mainly about vertical angles, actually. So these 4, where did it go? Yep. So 7, 8, 9, 10. Most of you did really well. Got the right answer. But I just want to make sure that everyone is understanding this good. So number 7. Now, so this is about vertical angle. So you just got to recognize that this is a vertical angle. So if we go back to the definition of vertical angles, the angles on the opposite sides, they are equal. So, well, the answer is actually pretty straightforward. It's equal to 89. But the thing I want you to notice is that this angle, now these two angles, I'll use a different color. So the blue angles are equal to each other, but they are not 89. They are not equal to these two angles. These two angles are equal, and these two angles are equal. But the red angle is not equal to the blue angle. Oh, it can be equal, but it's not necessarily equal to, and most of the time it won't be equal. Because if you can imagine like two angles like this, right? Like by vertical angles, this angle is the same as this angle, Yeah, these two angles are the same. And then also the blue angle is again the same as this blue angle. Like these two angles are the same. But I think it is very obvious in this case. Like this is not very obvious, but this one is very obvious that the red angle is not equal to the blue angle. And remember the line, I can draw it whatever the way I want. Like I can draw it like this. I can draw it like this. The vertical angles are still equal no matter what. But it is very obvious that this angle is not equal to this angle in this case. And this one is not so obvious, but I hope you guys understand that this angle and this angle, they are not necessarily equal. They don't have to be equal. In fact, the only time that all four angles are equal are when you have four right angle. That's actually the only time that all four angles are equal. So that is the only scenario. Okay. So they are not, these four are not equal. So you cannot just do 360 divided by 4 and get the right answer. No, doesn't work like that. So always remember, only the opposite angles, they are equal. So two of them are equal and these two are equal. Now for number 8, how I drew it, I think that this is not a straight line. So therefore, there are actually no vertical angles here. Because the only way you can form a vertical angle or vertical angles are when you have two straight lines intersecting. Two straight lines intersecting. But here, you don't have two straight lines. You only have one straight line. And the other one is not a straight line. But this question should be pretty easy though. Or well, it's a bit tricky, I guess. But then now this is a straight line, so this here is a straight angle. So all you gotta do is 180 minus 73, and you can get 20. No, not 27. 117. Yeah. So this question, I guess, is hard in the sense that it is tricky. But then when you recognize that it is a trick question, how it's not vertical angles, then what you can do is use this as a straight line, and then this angle here. So this big angle is 180, and you simply minus the 73 to get 117. Yeah. And number 9. Here, this one is two straight line intersecting. So there are actually vertical angles here. So this one and this one is a vertical angle. Or since it's asking for the x, so too big. We probably want to focus on this one. So we know that 2x are equal to 80. Because this is by definition vertical angles. These two angles are equal. And this angle is x plus x, right? Formed by x plus x. So then this is 2x over here. It's equal to 80. So x is simply 40 degrees. Now number 10. I didn't give you, oh, wait, this one. I hope you guys saw the message. I apologize if this is not F. This should be E. I sent it in both the Discord chat and the WeChat group. So this is supposed to be E. Yeah. Now, so this question is again vertical angles. Now again, all these I think there are 12 over here. 1, 2, 3, 1, 2, 3, 4, 5, 6. Yeah, 12. These 12 angles, although they look very similar, they are not all equal. So you cannot do 360 divided by 12. So no, because they are not necessarily all equal. It's just how I drew it, make it look like really equal. Because like I can have an angle like this. Like I can have multiple angles. And I hope it's like this angle is obviously different from these three. And even these three, they're not equal. Or they don't have to be. Okay. So now this is a vertical angle question. So A is this one. So A, right? Now H is all the way over here. Well, yeah, I'll first draw all these. So C, and then D, and then L, and then E. So these, they are everywhere. So but at first glance, you can't really like make any angle with it. But what I want you to recognize here is vertical angles. So the H, right? This is the H. So that means H and B are equal. H and B are equal. So H is also equal to B. Okay. Now C. Well, C is just C. D and D. E is here. And then L and wait. Yeah, L. Yeah. L here. L and F are equal. So this is equal to F. Now, so when at the end, you will have A plus B plus C plus D plus F plus E. This here and this here, they are exactly equal by vertical angles because H is exactly equal to B, H is exactly equal to B, and L is exactly equal to F. So, and then, so A plus H is A plus B, same thing, plus C plus D, plus L is plus F, same thing, and then plus E. So now you have A, B, C, D, E, F. And what is this over here? Oh, it's a straight line. See? Straight line. And then, yeah. See, this gray angle, this entire angle is straight line. And when you have a straight line, it's 180 degree. That's a straight angle over here. So that is number 10. Okay? So any questions about these four? No question? Okay, good. So I guess we will move on to to the solving some. So last day, let's remind ourselves what we did last time. Here. So we looked at lines, all these definition stuff. So an angle is a rotation, and then the different types of angle, and then you also got to recognize some in the homework. And then we looked at complementary angles and supplementary angles. Now these are really important and don't get them mixed up. So complementary is when you have this corner over here and they add up to 90 degrees. And then supplementary is a straight line, angles adding up to straight line. And then, so yeah, and then we did something here. And then vertical angles, which I talked about a lot just now, how these two, the opposite angles are equal, and then these two opposite angles are equal, but they're not necessarily equal, all equal. And then we looked at with the parallel lines and the transversal. So how this is an alternate interior angle. So look at the Z. Oh, and like if you have another transversal over here, this angle and this angle, they are equal. Yes, they are equal, but then they're not called alternate interior angles. But so how you would show that they're equal is that this angle is corresponding angle with this angle. So that means these two are equal. So corresponding angles are equal, right? And then since this one and this one are alternate interior angles, then alternate interior angles are equal. So this is equal to this and this is equal to this. So this must be equal to that. But these are not called alternate interior angles though. So just keep that in mind. And then corresponding angles, so they are equal like this. So it's kind of like an F, I guess. So yeah, I guess you can treat it kind of like an F, and then it's like the corner beneath the lines. And then same side interior angles, they add up to 180 degrees. So these two angles. So yeah, so this is a Z. Alternate interior angles is a Z. Corresponding is like an F. And then same side interior is like a C, I guess. Yeah. So I go back here. And then now we look at examples. So this here is 28. And now I want you to find A, B, C, D, E. Yeah, I just want you to find all the angles. So I only give you one angle, but you can actually find all the angles. So go ahead and give it a try, and then type in the chat the answers. AIA equal just and then CA, so corresponding angle equal, and then same side interior add up to. Okay, so So pretty good. Looks like many people are getting it. So yeah, there are actually only two measures here. One is 152 and one is 28. Now, so there are many ways to find out what an angle is. So for example, let's just use A for example. By SIA, I get that A plus 28 is 180. So A is 152. Now, the other way you can find it out is if you have found out about D first. Well, D is AIA. So this is the Z. So by AIA, D is just straight up equal to 28, right? And then now by supplementary angle. So not really any of this, but like supplementary angle. So we have 28, no, yeah, 28 plus A is equal to 180. And again, A just turns out to be 152. And actually, you can find that B is a corresponding with 28. So B here is a corresponding angle of 28. And then by supplementary angle again, 28 plus A, so this is a straight angle. A is equal to 152. So like this is why there are a lot of ways to figure this out. So I'm just going to use the one of the ways. None of them are easier than others, and none of them are harder than others. They're just different ways of doing it. So by SIA, so same side interior, we have A plus 28 is equal to 180. So A is 152. And then now I want to find B. So instead of using, instead of using these three, I'll just straight up use supplementary angles. So supplementary angles, we have A plus B is equal to 180. So then 152 plus B is equal to 180. So B is equal to 28. Now C. Actually, for solving for C, I'm going to use vertical angles. So this is the symbol for angle, okay? So these two, C and A are vertical angles. So A equals C, just straight up as that. So C is 152. A is 152, so C is 152. So then, now we're going to do D. Well, I'm again going to use vertical angles because B is just 28. So vertical angle, we have B is equal to D. So, and since B is 28, D is 28 as well. So now E. Well, E, I'm going to use corresponding angle now, just for change. So E and C, they are corresponding angles. So C and E, well, corresponding angles are equal. So corresponding angles, E is equal to C. And C, what have we figured out C is? 152. So E is 152. And then F, there's still F. F, I'm going to use vertical angles. And then, so it's vertical angles with 28, so F is just straight up 28. And then lastly, we have G. So G, there are different ways. Let's use corresponding angles again. So A and G, they are corresponding angles. So we have a corresponding angle. G is equal to A. So G, and then A, as we figured out, is 152. So G is again 152. Okay? So that's it. Any questions? And again, like E over here, right? Is alternate interior of A, so you can figure out that way that E is 152 as well. So that is like, I guess, there are harder questions, of course, but what you are doing is essentially the same. You use these two rules, and then with supplementary and maybe complementary and vertical angles, just like so, 1, 2, 3, 4, 5 rules, and then you essentially solve most of the angle problems in middle school, even at contest level. That's just how it goes. Not hard. But now here is the triangle. So this is a bit harder. Actually, I would say it's a lot harder. So a theorem of triangle, so is that all interior angles. Wait, no. What am I doing? The sum of interior angles of a triangle is 180 degrees. So what I mean by that is that whether it's this triangle or this triangle or this triangle, doesn't matter. Oh, that's a bad one. Yeah. Any triangles. The interior angles are these. So this one, and this one. These are interior angles, okay? And same here. So 1, 2, 3, and here. Again, 1, 2. The triangle has 3 interior angles. 3 sides, 3 interior angles. The sum, so the red angle plus the blue angle plus the green angle, in all these triangles, they are always equal to 180 degrees. So that is the theorem. 180. Always. No matter what the shape of the triangle is. The interior angles are equal to 180 degrees. Now, the hard part is, so I'm just telling you this, and you can believe me because it's true. The hard part is for you is to prove it. And so you're typing in the chat, so you can't really draw anything, but I hope you can still explain it to me so that maybe I get what you're saying. So I'll draw a good diagram, okay? So I'm actually gonna use ruler this time. So, um, so something like this, yeah. And then yeah. So this, yeah. So prove this. Red, blue, green. So red plus blue plus green is equal to 180. So go ahead, try it out. I will give you at least 10 minutes to try this. I know Tim knows it because he has done it in the past with us, but everyone else. So to prove this, all you need to use, let me see. Actually, all that you need are these two. Yeah, you don't even need the third one. So I'll copy this to here. Yeah, all you need are these two to prove it. Alternate interior angles are equal and corresponding angles are equal. Yeah. So I will have 3 hints for you. And then hint number 2. Hint number 3. Now, so first I want you to think about it yourself. But if you are really struggling and don't know where to start, just type in the chat and ask for a hint and I will show you a hint. Okay? So, yeah. Now, I really want you guys to be doing this right now, okay? Like, I can talk about it, no problem. But I just want you to have this exercise of thinking about proving stuff. So if you, yeah. So this is a bit different from what I have been asking you to do, to like find like x, find the value. Here, I don't want you to find any value. I want you to tell me, show me, explain it to me why this is true. Like the blue, red, and green, they add up to 180. Like that is no doubt about that. But why is that the case? And in fact, you cannot find out what each of these values are. Like from this drawing, you cannot, because like I can literally just like change this to here. Like instead of like I could do this, like erase this and then draw out like this line. Like I can change it like this and then still have red, blue, and green. Like I just changed an angle, but they still add up to 180. So what I'm asking you to do is not to find out what the angles are. And that is impossible. You cannot find out what the angles are. I want you to show me why they add up to 180. They always add up to 180. No matter this or this or this. Like all these triangles, they add up to 180 degrees. Okay, I'll give you a first hint. So you have to draw in a line here. So yeah, somewhere on here. Parallel line, see, I specified, not just any line. So parallel line. So that means it has to be parallel to something. So try drawing in a line. So draw a parallel line at green equal. Okay, so do you mean like what do you mean green equal? So like this? Like a parallel line over here? Uh,
Yes.
yes, okay. So and then what? So this one is parallel to this one. Okay. Oh no, that's not. I mean, so like this. Oh, actually, I just realized you don't even need this. Triangles are half of parallel. Okay, well, yes, that is a good point, but why are parallelograms 260 degrees then? It's actually the other way around, Olivia. So by proving that triangles are 180, you can prove that parallelograms are 360. So this is a good point, but not part of the proof. It's actually the other way around. So actually, I just gave you another hint. You don't need corresponding angles. All you need are alternate interior angles here. So now you join the line, and then you have all these angles here. How are you going to prove that is... Okay, I will give you the second hint. It's actually a reminder, to be honest. So a straight angle is 180 degrees. I just want to remind you that. And a straight angle is a line. I'll do this bigger. So see how I made this really big? That means it's really important. Just so you know. Okay, so are we stuck? You want the third hint? I'll give you the third hint. So hint number 3. And remember, you just want to show that they are equal to 180. Like I don't want you to find any values, okay? Like there are no answer per se, but like more of an explanation. Okay. So hint number 3. Find alternate interior angles of red, green, blue. And what do they form? Okay? So, Nobel, what do you think? Why are they 180? Oh, wait, not green. Red and blue only. You can't really find this. But Olivia? The The AIA of green, blue, and red forms 180 degrees when adding up together. So, okay, so what does that say about red, blue, and green themselves? You are saying that the alternate interior angles of them form 180 degrees. So what about those angles themselves? Very close. Just one more line of explaining. Mm-hmm. Yeah, and they are equal. So that is essentially it. They are equal. So that means they also add up to 180. Yeah. So yeah, good job. Um. Yeah, I guess I will. Unless does anyone else want to explain it in a way they feel like, uh, if not, then I will go on. So, anyone else want to explain it in a different way? Nope. Okay. So get rid of this. Now, so the first step is to join the number one. Join the purple line. Okay. And when you draw in a line in geometry, we call that an auxiliary line. So it's a line that helps us help us in the question. An auxiliary line, a helping line. Okay. And then number two is to recognize alternate interior angles. Right. So what do I mean by that? Well, the word one here, right? These two are parallel lines, so you can treat this as a transversal. So it's just kind of like this. So two parallel lines and one line that go through. Except it's sideways. So, well, yeah, it's sideways. So, but it's still alternate interior. So let me draw it. So this is the Z over here. This is the Z. So what this means is that this angle is equal to this angle. And I will draw with two red curves. But So the red ones are equal, right? Now, there is another alternate interior angle here. And that is this one over here. This one. This here is also a Z, right? So these two are parallel lines. And then you can treat this line here as another transversal. So on the opposite sides, they are equal. The blue ones are equal. So now what do you have here? Oh wait, recognize. So I will call this blue with a apostrophe up top, and I will call this red with an apostrophe up top. But you gotta recognize that this is equal to this, okay? And this is equal to this. So notice, now the third step is to notice that green plus blue apostrophe plus red apostrophe, what are they equal to? So the green, the blue apostrophe, and the red apostrophe, they are on a line, a straight line. So when you have a straight line, that's a straight angle over here. So this whole part here, this is a straight angle, like including this, right? So when you have a straight angle, it's equal to 180 degrees. Now these are the alternate interior angles. I don't care about red apostrophe and blue apostrophe. What I do care about is red and blue, just the original red and blue, right? So then, now you have green plus blue apostrophe plus red apostrophe is equal to 180 degrees. Now, by alternate interior angles, red apostrophe, it is the same thing as just red itself. And red is one of the interior angles of a triangle here, right? And blue apostrophe, by the same sense of alternate interior triangles, is exactly equal to blue, the original interior angle of this triangle. Now, if you need a reminder again, the triangle is here. Use green. So this is the triangle. Now always that we're trying to figure out the triangle, okay? And green, well, green is just green over here. Actually, I'll use a different color. Let's use, let me use this one. Yeah. So let me just highlight the triangle here. So to remind ourselves, we want to prove that the red plus the blue plus the green is 180. And we essentially have already done that here, the last step. So green plus blue plus red. So the alternate interior angles are equal to 100, add up to 180. So since this is equal to this and this is equal to this, that means the second line over here is also equal to 180 degrees, because you can substitute this in and it will be the same thing. It doesn't change anything about this equation. So that means it adds up to 180. So this must add up to 180 as well. And guess what? We just proven it. The red, blue, and green, they add up to 180. Okay. So, oh yes, and the green over here. They are, well, should be pretty obvious that they are exactly the same as well. I didn't change anything about them. So if you have three same things adding up together, of course the final would still be the same, and that is 180. Like if everything is the same, then the right side will also be the same. So they are the red apostrophe and the blue apostrophe. Those are the alternate interior angles. So any question about this? So this is, excuse me. So this is an example of like a question that doesn't ask for a value, but for you to explain using words and equations like math symbols to show something, to show a, like to prove something. In fact, you can call this a proof because we have just proven that the interior angles of a triangle add up to 180 degrees. So it's okay. Like I guess for most of you, this could be like the first time you ever seen like a proof where like the question doesn't ask you to find a value, it asks you to show something. So as you get more, as you look more into these, you become more familiar with them. Okay? So it's okay if you don't get it in the first try. So with this, I will just a quick example before we leave is 11. So just hope you guys kind of get it. So this angle is 89. This angle is 32. Quickly find this angle for me. What is this angle? Just this angle, really quick. So the interior angles add up to 180. $59, $59. Yeah, 59. 180 minus 32 minus 39. 59. Yeah, that's it. Okay. So that's it for today.